Good morning, students. From today, we are starting with our second unit, breakdown in solid and liquid insulating materials. Okay, we have completed breakdown in gaseous material, Townsend theory, and then streamer theory, and lot of many things. You can go through the previous videos. Okay, all videos I have posted on my channel. You can go through that so that you can understand how breakdown occurs in solid and liquid insulating materials. Okay, you might have covered in a very brief way in second year, but here one complete unit is there. And not only one complete unit is there, but also it is very important from the oral point of view, because experiment is there on solid, composite dielectric materials, and liquid we have completed that first experiment. So as experiments are there, oral examination is also there. So three experiments we have completed. Complete the journal and start submitting it. Okay. So let us start now the second unit. So syllabus of the second unit is like this: breakdown in liquid dielectrics. So we have to see different theories. In first unit we just completed 2 units, but here number of theories are there. Theories means it is just explained by some scientists how breakdown might be happening from their perceptions, from their visualization, or from their opinion. And you can put also your opinion, and you can just combine all. Actually, breakdown might be happening due to combination of all. But when we say theory, what theory says, that only we have to see. Okay, and then you can consider your logic, and then you can develop your own theories also. So you break down in liquid dielectrics, pure and commercial liquids we have to see. Then different breakdown theories: breakdown in pure liquid, how breakdown will occur in pure liquid, and how breakdown will occur in commercial liquids. In commercial liquids, we have to see four theories: suspended particle theory, cavitation and bubble theory, thermal mechanism of breakdown, and stressed oil theory. Generally, I am observing students get confused. So there should not be confusion. You have to keep clear picture of theory. What is that? Okay. So breakdown in solid dielectric materials, again number of theories are there. So intrinsic breakdown, electronic breakdown, avalanche or streamer breakdown. Now electromechanical breakdown, thermal breakdown. Now this thermal breakdown and this thermal breakdown, again students gets confused. So it is solid, it is liquid. So you have to keep distinct features of solid thermal breakdown and liquid thermal breakdown. Then partial discharge, internal discharge, composite dielectric material, properties of composite dielectrics, breakdown in composite dielectrics, and numerical also, problems also. Okay. So let us see what is mean by pure liquid, or how liquids are classified. Generally, liquid insulating material, we are just learning about insulating material. Liquid insulating materials are classified into three classes: pure liquid, and commercial liquid, and then commercially pure liquid. Means pure liquid can be very high, scientific means all, it will be very pure. But we can just have second grade pure liquid. Okay, so that is also one of the class: pure liquid, commercial pure liquid, and commercial liquid. Okay, or you can just say impure liquid. But some liquid will not have any impurity and very pure. But some liquid, commercially it is called as pure liquid, but it might have some of the impurities somewhere else, not in all the liquid. Okay, but here you can just see two classes are given. So liquid which are chemically pure, complex, its complexion is pure. Then structurally simple, simple structure, not too many molecules, not too many hydrocarbons, and bonding also simple. So structure also simple, chemical composition also pure. And they do not contain any impurity, even in the traces of 1 into 10 raised to 9. Traces of 1 into 10 raised to 9 means what? See, you imagine a liquid in a test cell. We have just tested liquid. And you imagine that liquid in a test cell. Now, when I will say pure liquid, when there will be no impurity in liquid which is near to the electrode, in the space of two electrodes, or it just, you can say, volume is very important. So when you will not find out any impurity even in the volume of 1 into 10 raised to 9, means traces, means large value, you will not get impurity, but somewhere else it might be there. So these are called as pure liquids. So example of pure liquid is N-hexane C6H14. But commercial liquids use as initial. Now when I told you another class, it is a commercial pure liquid, then you will just see that will be pure but in some less volume, okay, and the traces will be available in the test cell also, but not will come in the electrode. So that will be the commercial pure liquid. So the commercially pure liquid will be insulating liquids which are chemically impure. These are chemically pure, these are chemically impure, because commercial liquids means it will have number of impurities. So that impurities might be solid, might be gas, might be liquid, any types of impurities. So it is said as chemically impure and may contain mixtures of complex organic molecules. Now structure of this liquid will not be simple like pure liquid. It will be complicated, be complex. Number of hydrocarbon molecules will be there, and it is difficult to understand the structure of liquid, commercial liquids, and that's why breakdown theories are not developed. Okay, these theories are not developed due to the complex structure, but whatever theories are known, we have to just say what that theory says. Okay, what is happening actually we don't know, it is under research development. So clean dry oil has high dielectric strength. Now when oil will be clean and dry, definitely it will have high dielectric strength. Pure liquid will be having highest dielectric strength in megavolt per centimeter. Then commercially pure liquid will be moderate, and then commercial liquid will be having less than both classes. So you can just see when oil is clean and dry, it will be having highest dielectric strength. But this may not be due to the absence of all contaminants. See, means even if oil is clean and having very high dielectric strength, we cannot say that it is due to the absence of contaminants. Means no impurities there. We cannot say that. It may indicate that the number of contaminants present between the electrode is not large enough to affect the average breakdown voltage. I told you that between the electrode, oil volume between the electrode may not have impurity. And here again one step is there. Even if contaminations are available, it will not affect on the average breakdown voltage. Means it will not force exactly between the electrode. Okay. So example is transform oil. So we are just testing transform oil in the lab. So these are the liquid dielectrics. So transform oil is a mineral oil. Then examples of oils are synthetic hydrocarbon oil is there. Then chlorinated hydrocarbons are there. Then latest development like
Ma'am, the
MTH
picture
or
is not visible.
C2CL4, tetrachloroethylene is there. Then silicon oil is there and esters are there. So transformer oil is having generally 40 kilojoule per centimeter. We say for air, according to Indian standard specification, general breakdown strength is considered as 30 kilojoule per centimeter. But here for oil, we have to consider 40 kilojoule per second. Okay. 1 minute. I'm just, where is my pen? So 30 kilojoule per centimeter or 40 kilojoule per centimeter for the oil. So you must
Ma'am,
keep, yes, yes.
ma'am,
Okay, you can see in recording. Okay. So that is about the pure liquid and commercial liquid and commercially pure liquid. So when field is very high. Now what is mean by field? We have discussed. Field means electric field intensity. Okay. And when electric field intensity is very high, see 100 kilovolt per centimeter. Generally, we are observing breakdown of air at 30 kilovolt per second. I just told you. And commercial liquid, we are considering 40 kilovolt per centimeter. But now we are talking field higher, very high, double than that, 100 kilovolt per centimeter. The current not only increases rapidly, but also undergo violent fluctuations. So we have to learn now breakdown in pure liquid and breakdown in commercial liquid. And what is current growth? This I have discussed for the in our discussing first experiment, finding the breakdown equation of transform oil. Okay, so I have discussed this how the current growth will take place, and Townsend theory also we have seen. Okay, so when field is very high, 100 kilovolt per centimeter, current will not only increase rapidly but also undergo violent fluctuations. So you can just see this is the case for the field in hexane when field is very high, and this is when field is very means low field than this hydrocarbon liquid, means it is for commercial, and this is for pure you can consider. So you can just see what is the conduction current, what will be the current flowing through the insulating material, conducting current, what will be conducting current through the commercial liquids or when in presence of low field. So that we have to just see, and then we'll start one by one theory. So this condition is near to breakdown. So you can just see in pure liquid has very high dielectric strength. It will be in megavolt per centimeter, okay, or nearly or more than 100 kilovolt per centimeter. And now, how breakdown will take place in pure liquid, that we will also discuss. But current will be very steep. You can just see this is very steep growth, and then also very rapid fluctuations are there until breakdown occurs. When breakdown will take place, then circuit breaker will trip. Okay. So up to this, you can just see current growth is like this, and we'll discuss how this current growth will take place when we'll discuss breakdown in pure liquid. Now this is the just usual case, sample case. So when you will apply means sample means commercial where we test the oil. So when we'll just go on increasing field, generally here we are talking in field. Generally we increases voltage and we plot the graph for voltage. So you can consider when field is increased, gap distance we make same for one particular reading, and voltage we are varying. So electric field is we are varying it. So when initially when we'll go on increasing the voltage or field, then first slowly current will increase. Now, why this slow current occurs even if it is insulating material? It is due to the dissociation of the molecules. Okay. So, it is due to the dissociation of molecules. Means now see liquid is made up of molecules. It will be complex in commercial. So dissociation of molecules means splitting or ions will be there. Now we discuss in Townsend theory in gas how first initiating electron will come, and then it will collide with gas molecules. So somehow yeah, ions will be there. Ions will be formed in the liquid due to electric field. It is also high, even if we are saying low, but in terms of normal, it is in megajoule per centimeter. So it is quite high. So small leakage current will start flowing due to the dissociation of the ions. Okay, and then saturation will come. Means growth of a current will not be very large because field is not very high to have different phenomena happening in the liquid. We consider primary ionization in gas, secondary ionization in gas. So in liquid, we cannot apply that primary ionization because in the gas, electrons are loosely bound and atom to atom distance in the gas is very large. So we can consider one electron come and collide with gas molecule, and then electron will be liberated. Now liquids are very higher breakdown strength, means they are very good insulating material than the air or gas. So we cannot say that a molecule will just inject the electrons. Electrons will liberate from molecules. No, because molecules are now here complex, and immediate we cannot get electrons and from the molecule. Okay, so saturation will come even if you are going increasing the voltage. Current will not increase too much. So saturation stage will be there. Now when field become will be very high, then some phenomenon will happen that we are going to discuss, and then break, and that due to that phenomenon the rapidly current will increase and breakdown will take place. So here is also it's exponential. We have derived the equation of transformer oil breakdown equation. Okay, so this is will be the exponential growth in the conduction current, and breakdown will take place. Now question is why current increases even if it is a insulating material, very good insulating material. What happens inside that and how breakdown occurs? So that is our discussions with the different theories. So you can just say here two figures are explained with pure or with you can just see here hexane, and for this hydrocarbon. Okay, this is pure, this is commercial. So initially when field is very less due to dissociation of ions, small current starts flowing. I have shown you that linear increase in the current. So that is due to the dissociation of ion. Okay, small current, usually it is called as leakage current. Okay. If field is increased further, current initially increases due to field aided electron emission from the cathode, but thereafter current attains a saturation value when field is high. So here I explain here current is also increasing, but it is just called as a saturation. And now when this increase in the current will start initially due to the field aided emission of the cathode. Means electrons will start liberating from the cathode. We have seen secondary ionization in the tungsten theory. Similar way, as field is very high, electrons from the cathode metal will get excited because field is very high, and that electrons will start arriving in the gap. Okay, so that is called as field aided emission or field aided electron emission from the cathode. But thereafter current attains a saturation value when field is high. The current multiplication, you know what I have said, field emission, that will be in the case of pure liquid, because in that case field will be very high. So this current will be due to the field aided emission, electrons emitting from the cathode. So the current multiplication also occurs from the electrons generated at the interfaces of liquids and impurities. Means very exponential current growth is due to current multiplication. So that we will see how it happens. So the increase in current by this process continues till breakdown occurs. So this we have explained how current growth occurs in pure and commercial liquids. Now generally what are the factors responsible for breakdown in liquid? Generally when question is asked in oral, you just say common factors. Means like gas pressure, temperature, humidity. But now you are in final year and you are learning high voltage engineering. So you should be very specific what question is asked. General factors are asked, or for gas is asked, for liquid is asked, or for solid insulating materials are asked. And there are some peculiar special factors which are only for gas, which are only for liquid, and which are only for solid, that you have to learn in depth. So generally breakdown voltage will depend upon field. What is the field? What is the field intensity applied? So here in liquid we are talking about the field. Then cathode work function. Cathode work function means what? At what electric field when you are applying some voltage to the cathode and anode, at what electric field intensity of the cathode electrons will starts injecting from the cathode. Okay, so that is called as work function, cathode work function. If cathode is made up of copper, it will be having less work function. If it is made up of steel, it will be having higher, because you can just see conductivity of the every material is different. So energy required to inject electrons from the cathode will be different, and that is called as the work function, cathode work function. Then liquid viscosity. Now in case of liquid, viscosity is very important. Okay, so how viscous liquid is? If liquid is too viscous, then how electron and molecules will be means disassociations will be started, and how movement will occur if liquid is too viscous. But if liquid is very thin, if viscosity is very less, then what will happen? Then you can say the mobility of ions and whatever free electrons, they will start moving very easily if viscosity is very less. So viscosity is affecting on the breakdown. But here again one factor we have to consider, temperature. Okay, if it is viscous, then another effect is that cooling. If I will say liquid should be too high and viscosity should be too high, it should be viscous, so that this mobility of electrons or ions should be very less. Breakdown should not happen earlier. If I will say, then if liquid is viscous, means I am saying cooling should be cooling will not be proper. cooling is not proper, because viscous means again cooling effect will not be too much, because liquid is not able to move between the two parts, and temperature will increase. And if the temperature of the parts and liquid will increase, then again breakdown will happen earlier. So we do not want viscosity too high or too less. So viscosity should be optimum. So this is having again both effect. Which is predominant over what? That is very important. So we will say that optimum viscosity. Then density. What is the density? Means how many molecules are there per unit volume of that liquid. So density is also very important. Then gas separation. So gap separation means what is the gap distance? That is, of course, gap separation, gap distance will be for all insulating materials, whether it is solid, liquid, or gaseous. Then temperature of cathode. See, for here in liquid, we cannot say that only temperature. In gases, we say only temperature, because that is the temperature, ambient temperature, surrounding temperature. But here, temperature of liquid will not become very too high immediately. So temperature of cathode we have to say, because we are applying very high electric field, and due to that very high electric field, temperature of electrodes will go on increasing, and therefore it's very important factor in the liquid temperature of cathode or electrode or anode, both same. Whatever we say for cathode, that is true for anode also. So the liquid temperature, we are starting process from cathode. So generally we say cathode. So the liquid temperature, here now temperature of the liquid is there. Temperature of cathode is there. Temperature of cathode will be higher than temperature of liquid. Okay. But this is important, and viscosity will be maintaining or controlling this liquid temperature. And molecular structure of the liquid, that is always there, which gas is there, which solid is there, which liquid is there. So composition of the insulating material is always there, but here we have to see molecular structure. And for liquid it is very predominant, dominant factor, because molecular structure of liquid is not completely known, complex if it is there. That's why difficulty is there to understand what might be happening exactly. So molecular structure of the liquid is very important. And now you have to remember typical breakdown strength of liquid. 40 kilovolt per centimeter I told for commercial, and for pure it will be in megavolt. So here it is given hexane 1.1 megavolt per centimeter. Megavolt, benzene it is 1.1. Transform oil it is given 1 megavolt per. So this is pure transform oil, mind you, not general hour. So our transform oil is minimum, it has to be 40 kilovolt. 40 or 60, 40 to 80 kilovolt. Liquid oxygen. See, liquid oxygen is highest 2.4 megavolt per centimeter. So note down this, liquid oxygen is very best liquid insulating material. Now let us start with the breakdown theories one by one. So conduction and breakdown in commercial liquids. We are starting first commercial liquids, and then after that we will discuss pure liquid. Okay, pure liquid there is no theory. There is only one theory for pure liquid, and that is from the field aided emission. Okay, so now there are different theories. First is suspended particle theory, then cavitation and bubble theory. Third theory is the thermal breakdown is also there, and stressed oil theory is also there, because in syllabus thermal breakdown is also mentioned. Okay, so four theories are there. Now, what is this epsilon 2 and epsilon 1, epsilon 2 and epsilon 1? Here in liquid, permittivity of liquid plays very important role. And number of breakdown theories, we just take help of impurity in the liquid, because we are talking breakdown in commercial liquid. And breakdown in commercial liquid, definitely we will take help of impurity only. So what is the permittivity of impurity? And what is the permittivity of liquid? It is very important. So if epsilon 2 greater than 1, it is suspended particle theory. If cavitation and bubble theory, if epsilon 2 is less than epsilon 1, then it is cavitation and bubble theory. So let us see that one by one. So let us see first theory, which is suspended particle theory. Okay, 1 minute. I'm not getting my pen. Reasons responsible for breakdown. Now, how we will explain theories? any theory in generally solid or liquid, you have to keep certain points. What are the reasons responsible for breakdown? And according to theories, what are the different factors which affects on the breakdown? Okay, because I told you there are different breakdown factors which are affecting. For gas, it is different. For solid, liquid, it is different. And you have to keep certain special factors in mind. But here, according to theories, also, you have to keep what are the different factors affecting on the breakdown voltage. Because every theory takes example or reason, some different reason it is considered. So, as reason is considered different, then factors affecting on breakdown voltage is also different, so that you have to keep in mind. So here let us see suspended particle theory. Now, as it is a suspended particle, means what? In the liquid there will be something suspended, and of course it will be impurity only, because I told you in commercial liquid impurity is there. And then in suspended particle theory means some suspended impurity in the oil is considered. So what will be the reason responsible for breakdown? So commercial liquids may have fibers or disposed solid particles as impurities, which may lead to breakdown. So definitely reason responsible for breakdown in suspended particle is suspended particle or suspended impurities, like some fibers of the cloth or some paper fibers, some tissue, so or disperse solid particles. Suppose chalk dust. I am conducting now experiment in the lab, and we are finding breakdown in the liquid. Some chalk dust may fall in the liquid. Some suppose we are filtering that oil from the paper filter, then that paper traces will be there, or cellulose will be there. Some fibers will be there. As it is commercial liquid, that solid impurities are considered. Okay, so that is responsible for breakdown. Now, if epsilon 2 is the permittivity of suspended particle. Now here suspended particle impurity permittivity is considered epsilon 2, and permittivity of the liquid is considered as epsilon 1. Now situation is here epsilon 2 is greater than 1. We already just seen when epsilon 2 greater than 1, suspended particle, and when is epsilon 2 less than epsilon 1, then cavitation and bubble theory. Okay, so if epsilon 2 is the permittivity of suspended particle and epsilon 1 is the permittivity of the liquid. Now here one equation is given. Depending upon that permittivity, force will exert. Now let me show you. This pen is difficult to use. Let us see. So if this is the test cell and if this is the liquid, okay. Now suppose this is some impurity particle is there. Now here our electrodes are there. My pen, I am not getting my pen where it is gone. So if suppose these electrodes are there. Now when impurity is there in the oil, force will exert on this impurity to bring that suspended particle in between the electrode. Because see, it is a suspended, it's very free to move. Imagine chalk dust is there, or imagine some fiber has there here, or imagine some paper fiber or some cellulose. Now, what will happen? You are applying very high electric field across the electrode. As very high field is applied across the electrode, what will happen? Here it is the electrostatic forces. So, and these particles which are suspended, they are very light and free to move. So, all these force will exert here to bring that in the gap between the electrons. So if R is the radius of spherical particle, if R is the radius of the spherical particles and applied field is A, then the particle experience a force F. And what will be this force, electrostatic force? That force is given as 1/2 into R cube. R will be the radius of suspended particle. So what is the impurity? So radius of the suspended particle. If it is large or if it is small or large. So that is R cube. So it will be proportional to, if it is large, definitely force will be large. If a suspended particle radius or small size is there, this R cube will be small, force will be small. Into epsilon 2 minus epsilon 2, epsilon 1. So epsilon 2 is the permittivity of the suspended particle. So if permittivity of suspended particle is higher than epsilon 1, this will be positive. Okay, and if suspended particle is having higher permittivity, so definitely this force will be higher here. But at the same time, this denominator will be also large. So you have to see that. So it is again gradient E. So this E is the electric field intensity square will be there. So you can find out force will be exerted, and due to that force, that particle will be coming in the gap. If epsilon 2 is greater than epsilon 1 in case of presence of solid particle. Why this permittivity of impurity is higher than liquid? Because we are considering impurity solid particle. In next theory, gas and bubble, it is not solid. So that permittivity will be less than the liquid. Because permittivity of air is less than liquid. Permittivity of solid is higher than liquid. Okay. So we are considering in this theory solid particles. So definitely permittivity of solid is less, is higher than the liquid. So solid particles like paper in liquid, force is directed towards areas of maximum stress. So force will be directed to bring that impurity in the area of maximum stress. Where is maximum stress? Means intensity. Stress means intensity. Four means it is the 4. So this is the maximum stress area. What will be the stress here? Away from the electrode, it will be less. It will be less here. It will be less here, but force is very high here. So the force will be in the direction of areas of lower stress if only gas bubbles are present in the liquid. So for gas, it will be in the area of lower stress. For solid, it is in the area of higher stress. Okay. So that is the situation. Now this force drives the particle towards areas of maximum stress if the voltage is continuously applied. DC or duration of voltage is long AC. Means our general practice is we are continuously varying the voltage, and we are continuously varying the voltage. So slowly all these particles will be driving here in the area of maximum stress, means between the electrode. Now, thus, a stable chain will be formed because one impurity has come here, one impurity has come, second impurity has come. So, after some time, what will be situation here in the test cell? Situation in the test cell will be, these are suppose electrode. Excuse me, I'm not getting my pen. So now here one impurity, second impurity, suppose third impurity is there. So force is maximum when area radius of the particle is very large. So first it will arrive, so that it will be in the maximum stress. Then this will come. So it will come here. Then this will come. This will be drifted towards the area of maximum stress. Then this will come towards the area of maximum stress. This will come. Now what is happening here? Chain is formed. Now you tell me, we are observing liquid dielectric material where the dielectric strength, breakdown strength of liquid is very large. Liquid is having very large dielectric strength. So here you are just considering now chain of this suspended particle has formed, which are solid material like paper, fiber, cellulose, tissues. Now dielectric strength of that solid is very weak than the oil. So you are forcing the weak material inside this. You means that forces. So you are observing weak suspended particles are there in between very high stresses. So what will happen? This will rupture immediately insulating strength of this will rupture and it will start conducting. Ionization surrounding this will take place. Heat will generate, gas will generate, and then temperature surrounding this particle that will burn out. And then all weak gases and then the burn particle, all the weak particles will be formed. So here this will lead to breakdown. So see, a stable chain of suspended particles can form which may bridge the electrode gap. If number of particles are more, if number of stable chain of suspended particle is formed and breach the electrode gap means from one electrode to the another electrode, that suspended particle chain will be formed and then it will lead to breakdown. Why it will lead to breakdown? Because weak materials are there between the electric field, high stressed, high electric field intensity. In case of less number of suspended particles, suppose chain is not formed, if less is number of suspended particles, there may be a single conducting particle between the electrodes. It will give rise to local field enhancement depending upon its shape. Means if suppose only one particle is there, it will burn out. Breakdown of that particle will be taking place and then that will lead to the gas formations in the liquid, means some weak products in the liquid, and definitely it will go on enhancing. Localized field will be there, means localized local field enhancement will be there depending upon the shape of that impurity, and slowly weaker regions it will, like a corona discharge, small regions that ionization will start. So local breakdown occurs near the particle when field exceeds the breakdown voltage of the liquid and the gas bubbles are formed which may lead to the breakdown of the liquid. Okay. So that is the suspended particle theory. So impurity particles and its permittivity. Impurity particles, how many particles are there? What is the permittivity of that particle? Depending upon that, and permittivity affects the breakdown strength. So suspended particle theory, breakdown strength will be significantly considered with the permittivity and number and size radius of the impurity particles. So larger the size of particle, the lower will be the breakdown strength. Yes, because if the larger is the particle, then force will be larger. If force will be larger, then breakdown voltage will be less. The values of breakdown strength of liquids containing solid impurities will be much less than the values for pure liquid. Of course, because in pure liquid there will be no suspended particle, there will be no gas molecule, there will be no traces of impurity. Then how breakdown will take place? Okay. So now what are the reasons responsible for the, this is cavitation and bubble theory. Okay. So suspended particle theory, have you understood? Suspended particle theory, have you understood? If not, then ask me the doubt. Now, in cavitation and bubble theory, second theory, cavitation and bubble theory are same. Means not much difference with the suspended particle theory. In suspended particle theory, we consider solid impurity. Here we'll consider gas or bubble. Okay, gas or bubble. So reasons responsible for breakdown are definitely, according to this theory, a kind of vapor bubble form is responsible for the breakdown. Okay. Now here it is bubble theory and globule theory. I will tell you globule theory also. Bubble means liquid, vapor bubble, and globule means will be the droplet. Okay. Globule means some another drop. Suppose water or some another liquid which is weak than the main liquid. So that is globule. And when gas is there, vapor bubble is there, it will be bubble theory. Okay. So cavitation and bubble and globule theory. So vapor bubbles may form in liquids due to following reasons. Now why vapor bubbles will be there in liquid? Okay, liquid is commercial. We are talking breakdown of commercial liquids, but there are different reasons why bubbles will be there. So see what are the reasons. There are four reasons. So between the space charges, electrostatic repulsive forces may exist and they may be sufficient to overcome the surface tension. So when you are talking the liquid, um, see, when you are talking the liquid, You are just considering liquid level is like this. So what is above this? Above this is air. Above this is air. And now air pressure is acting on that. So some air bubble may just overcome the surface tension and trap in the liquid. So between the space charges, electrostatic repulsive forces may exist and they may be sufficient to overcome the surface tension, and like this that air bubble will be there. Then electron coolage, because you are applying field here, no? You are applying very high field here. That is always there. Then electron collisions causes dissociation of liquid molecule and thus gas is produced. So liquid is there and some liquid gas molecule may dissociate, means separate, and that separation of the gas molecules will just create sorry, that separation of the liquid molecule will just create the gas. Okay, because in liquid something is happening, you are heating, you are giving very high electric field, means some dissociation of molecule will take place and due to that gas will take will be created. So electron collisions causes dissociation of liquid. Why electron collision? Suppose one ion is available, then that will collide with the liquid molecule, and that liquid molecule will also dissociate like gas. Means suppose any another gas liquid is there, that will be weak, and that may happen. So electron collision with liquid will dissociate that liquid molecule, and therefore gas will be produced. Because when liquid will be heated and you are giving very high fill, definitely gas will be created in the liquid. So gas pockets may be available at the surface of electrode. Okay, these electrodes are there, but some gas pockets may will be available during the fabrication of these electrodes. Some air cavity might be there available. Okay, and due to that, this gas from the solid structure of cathode or electrode will start coming out, because this is also weak and you are giving very high electric field intensity to this. So ionization of this air cavities will take place, that will produce gas, and after some time you will see the gas. So gas packets may be available at the surface of the electrode. This is one reason. Then sharp points and irregularities on the, suppose one sharp point is there on this electrode surface is deteriorated and some sharp point has occurred on this. So what will happen? You are giving very high electric field. So this electrode is sharp, very sharp point on this. Sharp point. So what will be electric field intensity on this electrode surface? What is this is very small sharp point. What will be intensity at this? Very high. And due to high intensity, this material will vaporize. Because electrons will start injecting from this, it is very high intensity. So what is of course cathode material? It is a conducting material, so electron will get excited, and then you can just see it will explode, this tip will explode and it will create the gas bubbles in the liquid. Okay, so gas bubbles will be created. So sharp points and irregularities on the electrode surface causes vaporization of the liquid, but corona type of discharge. Now see here, gas bubble has entered. In Townsend theory, we consider one initiating electron has entered in the gap. Now in cavitation and bubble theory, we are consider gas bubble is there. How that gas bubble has occurred? Four reasons. Due to that gas pockets available in the electrode, due to sharp points exploding, or that due to sharp points on electrode, due to overcoming of this surface tension, or due to dissociation of molecules, liquid molecules. Four reasons. Now suppose gas bubble has entered, like suspended particle theory, gas bubble has entered. Now again force is very high in this between the two electrode, and as force is very high, what will happen to this gas bubble? The word used in the theory is bubble elongates. See, bubble elongates, and it bridges the gap. So what is the meaning of this bubble elongates? See now, this gas bubble is having permittivity which will be less than the permittivity of the dielectric material. Now this gas bubble is a weak dielectric strength than the liquid. and you are putting this gas bubble, this gas bubble has trapped in between the electrode, so definitely ionization of this gas bubble will take place, and as ionization means electrons will exit from this gas molecule, that gas bubble will ionize, and due to that gas will produce. So gas is increased means it is elongated. Again now it is breakdown or discharge or ionization of this gas particle has occurred. Again gas is produced. See, so bubble elongates and finally it bridges the gap between two electrons and breakdown occurs. So here see, due to above reasons there may be gas bubble available in the liquid. Electrostatic forces will act on a bubble and it will elongate in the direction of electric field. So elongation I have explained you. Okay. So when the voltage drop along the length of bubble becomes equal to the minimum value on the Passion's curve for the gas, in the bubble breakdown occurs. You know Passion's curve we have considered. What is that Passion's curve? It is in V shape. Okay. So this is the minimum potential breakdown voltage. This is breakdown voltage, Passion's law. Remember Passion's law. So with the increase in pressure, gap distance and product of pressure distance, with increase in PD, initially breakdown voltage will decrease and it will be minimum, and then it will goes on increasing. And when the value of product pressure and gap distance will be very minimum, then you can just see here voltage drop along the length of bubble becomes equal to the minimum value on the Passion's curve. So when voltage drop will be very required less, then the gas in the bubble breakdown occurs. Final breakdown. No? This is just what I told, it is partial like corona or ionization or heating of that and production of the gas molecule. But when it will be minimum and then it will final breakdown of the tech will take place. So here equation is given. You have to remember equation, okay? Because if you will remember equation, then you can just see factors affecting on that, or sometimes if problem is asked you can solve. So due to above reasons there may be gas bubble available in liquid. Electrostatic force will act on a bubble and it will elongate in the direction of electric field, and when the voltage drop along the length of the bubble becomes equal to minimum value of Passion's curve for the gas bubble breakdown occurs. So within two lines you can explain bubble, and global theory will be instead of air bubble it will be some another liquid globule. Okay, so see this, what will be the force, and this will dependent on permittivity of liquid, permittivity of the that bubble. Then sigma is the surface tension of liquid, of course, because we have considered that gas molecule will overcome surface tension. So what is surface tension? It is very important. So sigma is also there. Then R, radius of the bubble is considered. Then VB, voltage drop in the bubble, which will be minimum potential of the Passion's law. So what will be factors affecting on breakdown? From the equation you can consider breakdown strength will depend upon initial size of the bubble and it is affected by temperature of the liquid, because temperature of liquid also is important to consider the gas bubbles, and hydrostatic pressure also. So hydrostatic pressure of the liquid is also very important. What is the drawback of this theory? The production of the production of the initial bubble is not considered in this theory. Production of the initial bubble is not considered in this theory, and hence the results given by this theory do not agree with experimental results. What is the meaning of that? We see it is considered that bubbles will be there due to four reasons. But that bubble will be also will be in the means liquid itself, like suspended particle, so it is not considered. That reasons might be there, that itself bubble will be there in liquid, and if you will consider that bubble in the liquid like impurity, then definitely breakdown voltage will be very less, but it is not theory we consider in the theory, so that is a drawback. Okay, so cavitation and bubble theory, factors affecting on hydrostatic pressure also, surface tension also, radius of the bubble is also there, and in global theory just replace the word bubble with the globule. Okay, so these are the two theories. In next session we'll consider another thermal breakdown and stressed oil volume theory. Okay.